Yeah, welcome back. I hope you've been enjoying the Things Conference Spring Global so far. We're going to talk a bit about how to manage costs. But before we start, I'm Felix, and I have here with me Adrian, who is from the product team. So us from the commercial team, we rope Adrian in quite a lot actually if there's extra questions we want to answer. So he's also the perfect candidate who can help me today to outline a bit what to look out for if you want to keep the costs for a LoRaWAN deployment quite low. So Adrian, I brought you a use case. Quite typical agriculture has always been around in LoRaWAN. So imagine we've had a customer who wanted to start deploying an irrigation system. So let's say there's acres, we need roughly 10,000 or more devices to monitor the moisture, maybe to control the irrigation system, and a few hundred gateways to actually provide the coverage. What would you look at first when you were looking at costs for such a setup?
Well, the easiest one to start off with is simply CapEx, the amount of money that you're going to be spending on the end devices themselves and on the gateways. Those are upfront costs. You can easily negotiate them with your distributor, and those are generally stable. You're not going to have many surprises there as long as stocks are available for the end devices that you need. Starting from there, you are also going to be needing a network server. Those are again upfront. In the case of us, for our cloud service, you are going to be paying based on the number of end devices that you have registered. You can basically predict how your number is going to evolve over time, so those costs are not very hard to estimate. And starting from there, we get into things which occur only, or rather occur more often at scale. So first of all, when you are going to start deploying so many end devices, so many gateways, you are going to start thinking, okay, those are battery powered end devices at heart. I'm going to need to actually replace the batteries on those end devices. This is going to happen periodically. If you're lucky, 1-2 years, it's a very good start. Sometimes they can do more. But for some end devices, not many, just a couple of them, you're going to have lower times. Those you are going to have to factor in. I'm going to need to send someone in the field to change this specific battery or this specific device in case the device got broken. And you have to factor that this is probably going to happen. Once you go into tens of thousands, hundreds of thousands of end devices, this is a given. It happens, and what you care about is the fact that you can monitor this first, but also take it into account when you look at the feasibility of your project. You should always have a bit of a margin of safety for such events. Another thing that can happen is that your radio signal from the gateways is not as good. So you are going to have to sometimes move a gateway, add an extra gateway. It's not going to be a large percent of your fleet that you're going to have to move around, probably under a couple of percentages. If you have more, even less. But it's important to think about the fact that you're going to have to do those operations at scale. Radio, it's a beautiful thing, but it's also a shared medium, and it changes over time. So what could have started as a perfect signal in an area, suddenly you have people moving near your deployments, they start doing some radio things as well, and you may actually need a new gateway there. Not to replace it, but rather to improve the signal in that area. So those are things that can happen. You can think that you can predict them, but it's good to have in mind that this may happen.
Since you were talking about gateways, to have sufficient coverage and also battery life, so if you have more coverage and very sufficient coverage, could you actually save on the battery life on the device? So would you rather have more gateways to have a longer battery life, or less gateways?
Indeed, actually. So the gateways themselves over the past couple of years have gone down in price in general. So the price becomes better and better and better over the years. And you can actually save a lot on battery replacing by having better coverage. LoRaWAN network servers do this algorithm called adaptive data rate, in which, based on the signal strength between the end device and the gateways, they can adapt how much battery the end device uses. So it's going to be a lot cheaper to get one extra gateway and improve the coverage in one part of your deployment than to actually replace 1,000, 2,000, 5,000 batteries 2 times a year just because you had bad signal there. It pays off massively to actually take care and install more gateways while you're at that scale. It saves you more money on operations than it actually does on having people periodically replace batteries.
Which is also a huge reason why we do price per registered devices. Those devices deliver the value. They actually like are what we can grow together with, while gateways you can, even from the lowest tiers in the cloud service, add as many as you want. And that's one effect which we've seen became more and more important in the last years. But yeah, gateway is up and running, the devices have battery.
Yeah.
How about the connection to the network server?
Yeah, so depending on the type of deployment that you're doing, your gateways are generally connected via two backhauls. If you're lucky, you're going to have Ethernet, so it's just a cable that powers the gateway and also provides internet connection. And that one is stable, the cable may go down, but this is rare. In general, this is the happy case, but in some places you don't have this luxury. You're not going to be able to get either Wi-Fi or a cable in the area, so you're going to go with GSM signal. Basically, you're going to have a SIM card in the gateway. That particular SIM card, if you are going to need hundreds of them, this is another cost that you add, the subscription for those SIM cards. Now, the operators have special pricing models for those, but it's good to keep in mind that you are going to have a lot of traffic that you are going to pass through GSM. So in areas with lower densities, when I say density, I refer to the number of end devices that are in the range of the gateway, you are going to see tens of megabytes towards 100 megabytes. But some gateways which are in higher density areas or actually near other deployments. So if you're near a city, it's very likely that you're going to pick up some LoRaWAN traffic from there too. Those can go into the couple of hundreds of megabytes. It depends a lot on what you have there available. So but it's an important cost to keep in mind while planning and building your deployment.
Is this actually proportional? So could I test with one gateway and one device and then calculate that for multiplied by 10,000?
By 10,000, it's you are pushing the estimator a bit. If you say if I had one gateway, one device, it's not realistic, because if you recall how we started, we said 10,000 devices, 500 gateways maybe, something like this. So the proportion is a bit bigger, but you could. So starting small, having a couple of tens, maybe 100 end devices near two gateways, this is already a good estimator for that particular area. It's a good start, and even if you start with two gateways and 30 devices, it's still something. It's still, it becomes more and more accurate as you add end devices, but already when you have 2-3 gateways, 20-30 devices, it's already a good start, and you can start looking, okay, this is how much data I've used this month, this one is, if I added more end devices, is going to scale like this, and so forth.
Yeah, so perfect. Like, just sum it up, in our irrigation project, we have to look into the upfront investments, buying hardware, meaning devices, gateways. We can influence the service provision, rollout, okay, we have to install them once. But to maintain it, e.g. battery swapping, etc., that's service costs we can heavily influence with our behavior, so that's ongoing costs. And of course, like the network server is one part of that, which is your subscriptions. That's transparent for registered devices, so not dependent on gateways or traffic on it. But now, yeah, it's not dependent on traffic, but I remember like some afternoons, let's say, of heated discussions in the team. So yes, we do provide a service level agreement. So, right, like we make sure that the cloud service of the LoRaWAN network server is up and running and available from 1 to 1 million devices, however many you would want to add. And that service level protects our customers that we have to provide that service, right? But I know that you could actually set up especially larger deployments in a way that the customer would be in breach with the service level agreement.
Yes, so fundamentally the service level agreement gives you, as a customer, so as one party of the agreement, gives you a couple of guarantees. It guarantees how much the uptime the service is going to be having. It guarantees, for example, how fast traffic is going to be processed, and those guarantees allow you to build an SLA of your own. So you have our SLA, you have our guarantees, you build your own on top of it, and this whole chain of guarantees goes on and on. Now, the idea is that while we are providing those guarantees, we can provide them as long as the customer actually respects his requirements too. So one of the requirements that we have in our SLA is that end devices do not have time synchronized behavior. Now, that's a mouthful, What it generally means is, how we understand it and how we enforce it, is that the end devices send messages at predefined times. So this is not periodical behavior. We are not speaking about the fact that, okay, the device joins at 10:53 in the afternoon and starts sending messages every 10 minutes. That's fine. That's not an issue. The problem is when you have 10,000 end devices and all of them join at the same moment and send messages exactly at the same minute. 10,000 end devices sending a message at exactly 10:30,000, like to the nanosecond. It's a big problem. It's a big problem from multiple points. So first of all, you are hurting your own deployments. So the LoRaWAN runs over radio, and radio is a shared medium. If two LoRaWAN messages occur at the same time, you are going to have what are called collisions. Both messages may actually get lost. So you are going to actually have collisions between the messages that come from the end device. Because of this, the network server is going to say, hey, I'm going to need more messages from your end device. Please send them a couple of times more, and this is going to eat your battery. Because it eats your battery, it's actually going to add your service cost, because now you have to replace your battery more often. So that's something that's going to start affecting you immediately. As you add more devices, the probability of having a collision increases because all of them send at the same time. And that's definitely going to affect directly your costs, but it's also going to disable the SLA from our side. We do not allow this type of behavior, and it's important that while you are procuring those devices, while you are building the firmware, perhaps maybe because you are collaborating with a company that builds those devices, it's very important that you keep in mind the type of requirements that are going to be in your service level agreements, both ours and of our other services that you may use.
Exactly. So the time synchronization is one point. Are there, like, briefly, to at least mention the other factors which seem to be a bit minor than the time synchronization?
Yeah, so second one that's very important is, for example, join behavior. So the simplest example here is some older LoRaWAN devices, in case they had to rejoin the network, so negotiate the keys with the server and start sending your traffic. How they would do it is that they would retry periodically at fixed intervals. So they try now, they try in 10 seconds, then try in 10 seconds again. And what the problem is is that this synchronizes them over time. So let's say something happens to a GSM antenna. The gateway in an area goes down. Now, because the gateway in the area has gone down, all of the end devices in that area no longer have coverage. After a while, because they no longer have coverage, they no longer get any response from the network server, they're going to say, hey, maybe something happened, let's rejoin. And suddenly, all, let's say, 100 or 150 end devices in the range of that gateway are now going to actually try to rejoin. And this actually synchronizes them over time, because everyone went down at the same time, everyone tries to rejoin at the same time, and suddenly you have, again, time synchronized behavior. You have large amounts of devices that have become synchronized one to another, and you're suffering exactly the same symptoms as I discussed before. You're going to have collisions, low battery lifetime. It's even worse for the battery, because while joining, you're sending a lot more often than you normally would, so you're draining battery more often than you should. This is something that you should really be looking at your end device. The best way of doing this is doing what's called exponential backoff. So in layman terms, every single failure makes the next wait time become longer. So it's 1 second, 2 seconds, 4 seconds, 8 seconds, and so forth until it reaches a bit more time. And also to that, you're going to have to randomize this a bit, because otherwise, everyone went down at the same time, everyone tries after 1 second, everyone after 2 seconds, and we are back at square one. That's not good.
A lot of these issues which affect your operations and your service are connected to the device and who is manufacturing the devices, right? So it sounds like it is worth it to carefully select your device makers. You can check in with us as well on which projects we've had good experiences with device makers. Of course, we work with that ecosystem quite actively in order to ensure all these factors. And also here mentioning, yes, while on self-managed, like on-premise service, these effects will affect you, right? Like, so you will have to cope with the effects, while on the cloud service, this is something which we have to take care of. Of course, there is an SLA, there is a contract in there, but I would argue that on the cloud service, we have a way better chance to not only detect these kind of behaviors early on, and our support might reach out to you and say, okay, there is a behavior which might be bad for you or for us, like maybe not bad, but disadvantageous in that sense. So we have a chance to support here proactively. And in the end, like if we are at a point, like then we can still advise on how to go back to a sustainable operation. But all these factors are increasing your costs around deploying large ones, yes?
Yeah. So it's one of those costs that you don't think of immediately, right? It's something that becomes more and more visible the more end devices you have. So if you don't take care of it, you don't really look very well at the specification of your end device before buying all of those, before deploying them, because it's really hard to change them once they're in the field.
Right.
Then it's going to be costly. This is why you should look at all of those SLAs. We have some LoRaWAN best practices that we speak of, and make sure that your end devices respect them. Otherwise, it's going to be very, very costly to deal with this once the end devices are in the field.
Perfect. Yeah, I mean, you will find the SLA on our website, so you can review that anytime. You don't need to purchase anything. For that, to get access to these documents, like our end-user level agreement, have a look. And if you want to have Adrian on the passenger seat of your deployments, you can look into our support options. We do have our support team, which we can answer tickets within a few hours for you if you have very specific technical questions. We do offer also a consultancy package in which colleagues from our product team, like Adrian, who is there quite a lot, comes in for sessions. We discuss your agenda, very specific questions, so we can make sure that we map out all the risks in advance of your deployment or in the early phases of your deployment. And usually we see that this is a cost saving in the long run. Yeah, I think... Thank you for sharing. I will see you in the next consultancy sessions for sure. And let's hope that we don't add too many issues to that list. And we wish you like a good time at the conference. Enjoy the next sessions.
Bye-bye.